All right, welcome back. This is lecture 4 on 3 claims, 4 validities. So this is going to review Morling chapter 3 from the textbook. So after listening to this lecture, you should be able to differentiate the 3 types of claims: frequency, association, and causal. Ask appropriate questions to help you interrogate each of the 4 big validities. Explain which validities are most relevant for each of the 3 types of claims, and then state which kind of research study is required to support a causal claim. So, just to overview the chapter as well as this lecture, I'll review variables and types of variables, talk about the 3 big claims. I'll then go over the 4 big validities, and then wrap up with an issue related to prioritizing validities. All right, so first, just some basic terminology. So a variable is something that changes or varies. So the idea here is that we need to have at least 2 levels, which is another word for values, in order to have a variable. A variable can certainly have more than 2 levels or values, but you need at least 2. So really you can think of anything that can vary. So many psychological attributes. Okay, let's take your personality. You can have have more or less extroversion, right? You can be more or less shy. You can think about different values that you could have on that variable. You could also think of a variable as the state that you're born. Okay, so there'd be 50 different possible values. You could be born in any one of the 50 states. So these are all variables. They can just take on different values. A constant is something that doesn't vary. It stays the same. So it only has one level or value. So in theory, you could have a variable that could vary, but in a particular setting, it's a constant. So if you had only women in your study, as a for example, gender would no longer be a variable, but it would be a constant because it only had one level. You had all women in your study. Okay. Another thing would be if you included participants that were all 18 years old. Age could be a variable, but if every single person in your study is 18 years old, age stops becoming a variable and it's a constant value if everybody's the same age. Another important distinction is between measured versus manipulated variables. So in a measured variable, the levels of the variable are observed and recorded by the researcher. So you can have measured variables that might be height, IQ, gender, hair color. And then, of course, psychologists also measure more abstract variables such as love, stress, depression. And so we'll talk about kind of the difference between constructs or conceptual variables and how a variable is measured. Okay. But so really with a measured variable, you're just observing and recording the values on that variable. A manipulated variable, on the other hand, is when a researcher controls that variable. Usually they do this by assigning participants to different levels of that variable. So this is common in an experiment. So in an experiment, an example of a manipulated variable might be that a researcher assigns some people to take a test in a room with many other people, but some people are assigned to take the test alone. Okay, so the manipulated variable is whether or not they take the test with other people versus alone. It's a manipulated variable. Some variables can only be measured and not manipulated. So age would be one of those variables. You can't assign people to be a particular age. That's just a naturally occurring variable. They are that age. There's other variables that you could manipulate it, but it would be very unethical to do so. So if you wanted to do a study on the long-term effects of education, it wouldn't be ethical to assign some children to attend a high-quality school, but other to a low-quality school. Okay, so that's unethical because you'd be depriving the people that went to the low-quality school of a good education. So in theory, it could be possible to manipulate that variable, but it's not ethical. All right. There's other variables you could think about that they could either be manipulated or they could be measured. So, for example, you could look at the type of extracurricular activities that children do. And so you could measure, well, what are the extracurriculars that you're in? Do you do music classes? Do you do dance classes? Are you in karate, etc.? Alternatively, you could manipulate that variable by assigning some children to take music lessons or others to take like acting lessons or something like that. So you can have variables that can be either measured or manipulated, and it could be the same variable. In that case, what extracurricular activities do people participate in? Okay, so another distinction is between conceptual variables versus operational definitions of those variables. So in order to test hypotheses with data, researchers need to develop an operational definition. Okay, so or they need to come up with an operational variable. To operationalize means to turn a conceptual definition into either a measured or manipulated variable. Okay, so conceptual variables or psychological constructs are abstract theoretical concepts. Think about the concept of love, right? This is very abstract. If you actually wanted to study love, you would have to operationalize it in some way. You'd have to come up with some way to measure love. And you could think of all the different kinds of ways to do that. You could ask people how they feel about somebody, right? How much do you love this person on a scale of 1 to 10? You could look at other things like how long do you gaze into the eyes of your significant other, displays of affection, things like that. So there's different ways to operationalize an abstract concept like love. And we'll talk about that in subsequent weeks when I talk about and when you'll read about measurement and when I lecture on measurement. This table is presented in the book. This is just to kind of underscore the point of what it means to go from a conceptual variable to an operational definition of that variable. It incorporates the concepts of different levels of a variable, and then whether that would be a measured or manipulated variable. So I'm not going to read through the table, but just to point out that this is here in your lecture notes, and it's also something that I think is worth studying in the chapter because it will hopefully demonstrate these different concepts of conceptual versus operational, measured versus manipulated. All right, let's move on to 3 claims. So a claim is an argument that somebody's trying to make. All right. So psychological scientists use data to test and refine their theories and claims. There's 3 types of claims. Frequency claim, association claim, and causal claim, and I'll go over each of these. All right, so let's start with frequency claims. A frequency claim just describes a particular rate or degree of just a single variable. So a frequency claim only involves one measured variable, not manipulated, but measured variable. So when you read claims like 2 out of 5 Americans say that they worry every day, or just 15% of Americans smoke, 72% of the world smiled yesterday, 4 in 10 teens admit to texting while driving. Seems low, I feel like that's more. Those are all frequency claims. We're just describing the particular rate, often in terms of a percentage of a single variable. So that's a frequency claim. Association claims, on the other hand, is where we're making a claim that one level of a variable is likely to be associated with a particular level of another variable. Okay, that's the argument. So to have an association claim, you need to have at least 2 measured variables. variables that are associated are said to correlate. And so some examples of association claims would be people with higher income spend less time socializing. Okay, income is one variable, socialization is the other. Here'd be another one. Romantic partners who express gratitude are 3 times more likely to stay together. Okay, expressing gratitude is one variable. Staying together or relationship longevity is the other variable. People who multitask are better at it. Oh, people who multitask the most, you could say, are the ones that are the best at it. So you'd have like how good you are at multitasking, that's one variable. And then the frequency with which you do it, that's another variable. Eating dinner late is not linked to childhood obesity. Okay, so you could eat dinner early versus late. That's one variable when you eat dinner. Childhood obesity is the other, so how much a child weighs. All right. So those are all examples of association claims. Now, associations can be of 3 basic types. You can have a positive association, a negative association, or a zero association between 2 variables. Here's what a positive association looks like. This might be familiar from your statistics class. And so when we have a positive association, also known as a positive correlation, high scores on one variable are associated with high scores on the other variable, or low scores on one variable are associated with low scores on the other. What we have depicted here is a scatter plot. This is just one way to represent an association. It's a visual. What we have is one variable that is plotted on the x-axis, that's the bottom horizontal axis, and the other variable is plotted on the y-axis, which is the vertical axis. Each one of those dots represents a person in the study. Each person has 2 scores, 2 values. So for instance, this person right here expressed a high amount of gratitude, and they've been in a relationship for 7 years. Okay, this person here indicating that there's not a lot of gratitude expressed in their relationship, and they were not together long at all. I guess that would represent less than 1 year. But what we have here is a positive association, and we can see that from the graphical depiction of the data, is that we have this trend where we're kind of sloping, this upward sloping trend. We can also have a negative association. Okay, a negative association is sometimes called an inverse association or a negative correlation. Here, high scores on one variable are associated with low scores on the other. So what we see plotted here on the x-axis is amount of coffee consumption. On the y-axis, we have degree of depression. So here what we see is that there's a general trend for higher values on one variable, in this case we have higher depression, to be associated with lower values of coffee consumption. Okay, you can also state that a different way. Higher levels of coffee consumption are associated with lower levels of depression. So we have a downward sloping trend. And then finally, we can have zero association. So here in this scatter plot, there's no real association between variables. We'd say that there's zero correlation in this case between the time that dinner is eaten and childhood weight. So here we just kind of have just looks like a cloud of points where you can't really draw a trend line through that. There's no kind of upward sloping trend line or downward sloping trend line. Association claims are useful because they help us make predictions. Prediction is using an association to make an estimate. Okay, we don't necessarily know what will happen in the future, but the stronger the association between 2 variables, the more accurate prediction we'll have. So if we looked at some of those different associations, and we knew that in a particular relationship, let's just go back to this association. If we knew, for example, that there is an association between the amount of gratitude that is expressed between 2 partners in a relationship, and if we knew that a couple express a lot of gratitude, that would lead us to predict that they will stay together longer in their relationship. And we will do a better job at having an accurate prediction to the extent that we have a strong association between the two variables. Okay. So both having a positive or a negative association can help us make predictions, but of course a zero association cannot. Basically what that means is knowing that a child eats their dinner late or early doesn't allow us to predict their weight. So when there's zero association, it's no good for prediction at all. Okay, so moving on to the third, whereas an association claim says that there's a relationship between two variables, a causal claim goes further, and it argues that one variable causes changes in the level of another variable. So a causal claim is about cause and effect. Association is a prerequisite for causation. So in order for there to be a cause and effect relationship between two variables, they necessarily need to be associated. You can't have causation without correlation. Correlation comes first. But notice that a causal claim is stronger than an association claim. And because causal claims make stronger statements, we hold them to higher standards. So to go from merely being an association to being a causal claim, a study has to satisfy 3 criteria. So the first one, as I said, you can't have correlation without causation. You have to first show that the variables are related in the first place. Secondly, you have to show that the causal variable comes first, and then the effect comes after. So there needs to be what's called temporal precedence. And then third, there's no other explanations that exist that could explain the relationship between those two variables that are linked in the cause and effect relationship. So causal claims are really supported by experiments. Experiments are those that have a manipulated variable and a measured variable, and experiments allow us to make cause and effect conclusions because they satisfy the 3 criteria that I mentioned. So I know that was fast, but I'm going to review just a little later in this lecture. I'm going to go over those 3 criteria. Okay, so the textbook presents these, and I think it's very important. Language use is very important. So there's certain language and certain verbs that we use to represent an association claim, and then there's certain verbs that we use to represent a causal claim. And so you can kind of notice the difference in the left-hand column with these on the right-hand side of this table. And so you can see that the verbs on the right-hand side are much stronger, and they signify that one variable is the cause of another. So using the word cause would sure do that, but there's other ways to use causal language without using the word cause. Okay, so verbs that we use with causal claims tend to be much stronger language, whereas verbs that are associated with, that we use for association claims, tend to be more tentative. Okay, is that we use the word associated with, or less likely, or may predict. For those of you that watched the John Oliver Last Week Tonight segment on science in the news, you might have noticed that some of the headlines that are about research that appear in the news, they're often stated in causal language. So one of the headlines that was on his show was that late night snacking hurts your memory. That was a real headline. Late night snacking hurts your memory. So notice there's the word hurts. That's a causal claim. That is using language to suggest that it is because of late night snacking that your memory is worse. That's a causal claim. Notice that that's a different claim than saying late night snacking is associated with memory deficits. One is much stronger than the other. We could also say something like late night snacking, also an association claim. Late night snacking is positively correlated with memory deficits. That is, the more late night snacking, the more memory deficits. One of the points that he made, and I think one of the points I'd like to make in looking at this table in our language use, is that we don't want to be misleading with our language and with our verbs. So using a causal verb insinuates that there is a cause and effect relationship. And as I said just a little bit ago, you can really only demonstrate a cause and effect relationship by using a proper research design or methodology, one that is able to satisfy the three criteria of causation, and kind of the gold standard for doing that is an experiment. So just asking people questions on a questionnaire, like, hey, do you often eat late night? Are you a late night snacker? How often do you do that? And then maybe ask some people about their memory, like how good do you think your memory is? Or do you have trouble remembering things over the course of your day? That is a association-based design, and it can't rule out alternative explanations. So just one that I thought of is, if you're late night snacking, maybe you're not sleeping as much. You're up late eating food and you're getting a lot less sleep. So maybe it's the not getting the sleep that is the reason that your memory is not so good. You're tired, you're fatigued, you're not cognitively alert. Okay, so it's insomnia, getting up, kind of going to the refrigerator, doing the late night snacking. So it's not exactly the snacking that is the causal factor, it is the lack of sleep. So that's the problem with using causal language when there's an association. All right. So interrogating the three claims using the four big validities. I'm going to go over interrogating frequency, association, and causal claims. First thing, let's define validity. Validity is the appropriateness of the conclusion or decision. So validity is an overall judgment of the extent to which theory and evidence indicate that a claim is true. So whatever claim we're reading about in the research, whatever news headline, whatever claim is out there, we're trying to make a judgment as to whether that is a valid claim. Now, in short, we can say that valid is equal to true. If something is valid, it is true. However, it's a matter of degree. It's not all or nothing. In other words, we don't just say valid or invalid, but we try to say, we kind of come up with the extent to which, okay, it's a continuum. There's gradation, there's degrees of validity. And that's especially true when we're considering that we're going to be interrogating claims using four different types of validity. So you could have a research study or a claim that is kind of higher in one type of validity but lower in another. So it's not a matter of all or nothing, it's a matter of degree. So here are the four big validities. Construct validity is how well the variables in a study are measured or manipulated. You can also think of this as the extent to which the operational variables in the study are a good approximation of the conceptual variables. So I gave the example of love, okay, this construct of love. We could ask ourselves, well, how well does, having people rate on a scale of 1 to 10 how much they're in love with somebody, how well does that approximate the conceptual variable of love? External validity is the extent to which the results of a study generalize to some larger population or across other situations. So, for example, we might ask whether the results from a particular study that involved children from the United States apply to other children across the world, or even to other times or situations. Okay, so if it's an old study and it was conducted 30 or 40 years ago, does it still generalize today? Statistical validity speaks to the extent to which the data support the conclusions the study. Okay, so are the data strong? So it's important to ask questions about the strength of an association between two variables, statistical significance, the probability that the results could have been obtained just by chance, etc. So I'll be going into more detail about that. And then internal validity speaks to the extent to which one variable is the cause of another variable. Okay, so that one variable and nothing else is the cause of another variable. So this is just me. This is kind of not in the textbooks, but I just did want to make a point of mentioning. It's common to refer to different types of validity, right? Construct validity, uh, uh, internal validity, etc. And that's what the textbook author does, and so will we. Just personally, I prefer to think about ways to establish validity versus types. So in this way of thinking, there's only one thing, validity, and we use different techniques to establish the truth of a particular claim. So that's just, I don't know, that's just one of my things. Um, uh, but because the textbook author does it, we'll do it. But it kind of can confuse the issues to say like, oh, there's all these different types of validity. You can think of validity as kind of an overall judgment, right? Which means it's just one thing. And what we're trying to establish is, just how true of a claim is it? And we can do that multiple ways, by asking how well variables were measured, by asking how well the data supports a conclusion, by asking to what extent the results generalize. So there's different ways of getting at truth. All right, so interrogating frequency claims. So this is the way we do it, and so I'll just kind of do this by example. So here we've got a frequency claim, which is that 80% of college students report being depressed in the past academic year. So if we're trying to be a little bit skeptical and have a healthy degree of skepticism, we want to interrogate this claim. We want to interrogate the validity of this claim. And so to do so, we start asking questions related to these different types of validity. And so starting at construct validity, really what we're asking is, how well is that variable measured or operationalized? So the variable we're talking about is depression. Well, there's standard ways to measure depression, right? Like there's clinical inventories of depression. So we might have more confidence in the validity of this claim to the extent that a widely accepted and standardized measure of depression was used versus, somebody just making something up off the top of your head is like, hey, like, how do you, have you been feeling down? You've been feeling blue lately? People are like, what are you talking about? So we would want to use an established measure of depression. The external validity really speaks to how generalizable the results are. So if we want to make the claim 80% of college students, where did the college students who participated in the study come from? Were they from just one college? Were they from several colleges? Were they community college students, university students? Was there a good sampling of ages? Right? So we would want to add, what about majors? Right? So we want to say who actually participated. Okay, it'd also be important to ask maybe at what point in the year were people asked? Start of the semester, end of the semester, things like that. So we'd really have to take a look into when people did the survey, who they chose, what parts of the country did they come from, were they in a rural area or a city, things like that. And finally, the statistical validity is the extent to which the data would support the claim. So one thing that we look at in judging the statistical validity of a frequency claim is something called margin of error. And so you'll often see this reported like in political polls where a margin of error like plus or minus 5 percentage points is given. And so this is to differentiate between a point estimate and a population value. So 80% would be a single data point that comes from a study. Okay, so it's an estimate of a true population value based on a single study. So this study is telling us that 80% of college students report being depressed, but that doesn't mean that that's necessarily the true number, because quite likely in the study, not every single college student in, say, the United States was included. So there's bound to be some margin of error around that estimate, and the true value might be a little bit more or a little bit less. So having a margin of error that is low would give us more confidence in the validity of the claim, right? Having a margin of error that is high, like say 10 percentage points, doesn't give us quite as much confidence in the claim. Okay. Let's kind of do a similar activity with interrogating association claims. So here's an example of an association claim. Job satisfaction is positively correlated with job performance. Well, here we've got two variables, so when we're looking at the construct validity, we need to look at both variables and say, how well are both of those variables measured? How is job satisfaction measured? Are people asked how they feel about their job? Is there an established measure of job satisfaction that is commonly used by organizational psychologists? Was that used? Are there kind of multiple questions or multiple indicators of their job satisfaction, or is it just a single question? Same thing with job performance. How is job performance being evaluated? Very commonly, your manager or your supervisor is the one that rates your job performance. Do we believe that that is a true and valid indicator of one's job performance? Or would we be more convinced if job performance is measured in a more objective way, like the number of sales you made in a particular quarter, or the number of customer calls that you answered, things like that. Same questions, external validity, okay? For this particular claim, who were the employees? What were the jobs? Was it in a big company or a small company? So we need to say, you'd have to actually look at the particulars of the study and say, this particular study is claiming that job satisfaction is positively correlated with job performance, but are there any unique attributes of that study that makes me think that it would not generalize to other employees, other populations, other, if it's done in the United States, is that true in other countries in the world? The statistical validity, when referring to an association claim, is we need to consider three things. And so I'm going to spend a little bit more time talking about the statistical validity of an association claim. When interrogating the statistical validity of an association claim, we need to consider the strength of the association, the statistical significance of the association, and our confidence. So we will put a confidence interval very similar to that concept of margin of error that we had with a frequency claim. So you might remember this from your statistics class, but the association between two variables is just summarized statistically using a correlation coefficient. It's often called a Pearson correlation coefficient, and it's abbreviated with this lowercase r. So the correlation and the size of that correlation provides information about both the direction and the strength of association between two variables. Okay. Now the strongest correlations that you can get is either a perfect positive one, which is a perfect positive correlation, or a perfect negative one, which is a perfect negative correlation. So the strongest correlation is either positive one or negative one. Those are both equally as strong. They just refer to either a negative association or a positive association. The closer you get to zero, the less strong the association, and a perfect zero means that the two variables are not correlated at all. So there's some guidelines that have been established for interpreting the strength of a correlation coefficient. So a small effect or a small association would be a correlation that is around 0.1. Okay, so either positive 0.1 or negative 0.1. A medium correlation would be a correlation that is either positive 0.3 or negative 0.3. And then a large effect would be positive 0.5 or negative 0.5. So anything that is more positive than 0.5 or more negative than negative 0.5 would be a large effect. And of course, you can kind of be in between. Okay, so if you had a correlation of 0.2, that's somewhere between a small and medium effect. If you have a correlation of 0.4, that's somewhere between a medium and a large effect. But in interrogating the statistical validity of an association, what we want to look at is, well, just how strong is that association? And then, you can kind of map that onto a scatter plot as well. So you can kind of look at a visual display of the data and kind of get a sense of just whether you've got a strong positive versus a weak negative relationship. Now, the other thing to ask is whether that correlation is statistically significant. This will hopefully ring some bells from your statistics class, but when we talk about statistical significance, what we're talking about is the likelihood of finding a positive or negative correlation between two variables in a sample, even if there's truly a zero association in the broader population. So a correlation is statistically significant if there's less than a 5% chance that the correlation that we've observed in our sample could have been drawn from a population in which the variables were truly uncorrelated. That's probably a mind bender. And if that wasn't kind of well established in your stats class, you might be like, what is this guy even talking about? But it's a very unintuitive and even backwards process of establishing statistical significance. We start with a null hypothesis. You might remember that language. In this case, the null hypothesis is that there's zero association between two variables. They're not related. We then do our research study. We have a sample. Let's just say we get a correlation of 0.5. What we're asking ourselves is, what is the probability of getting a correlation that is this large or larger if in fact the variables are truly uncorrelated? And if there's a low probability, as in it's unlikely of getting such a high correlation, then that would rule out that the variables are not correlated. And I will point out that in your textbook, in the appendices, there's a review of statistics. So if some of that didn't make the best sense to you, or if it wasn't ringing bells from your stats class, it would be a good thing to review the information found in the appendix about inferential statistics. And then the other thing that we can ask when it comes to statistical validity is the idea of the confidence that we have in that correlation. So a correlation that's calculated in a research study is a point estimate. Just like a percentage is in a frequency claim, a correlation is a point estimate, right? So this is just a single estimate of some population value that's based on data from a sample, okay, from a particular research study. The idea of a confidence interval is that we can come up with a range that has a lower and an upper value that's designed to capture the population value. So for example, we might find in our research study that two variables are correlated at 0.35. Okay, so kind of like a medium-ish effect. But that there's a confidence interval around that point estimate such that the true value of the association between those two variables in the population could be as small as 0.27 or as large as 0.43. So we often come up with a 95% confidence interval, that we can be 95% confident that the true population correlation is between 0.27 and 0.43. And confidence intervals and statistical significance are related because if your confidence interval does not contain zero, you have a statistically significant result. All right, and so moving on to interrogating causal claims. So there's three criteria for causation, which are covariance, temporal precedence, and internal validity. Covariance is the idea that there's correlation. That's all covariance means, is that in order for there to be causation, there needs to be correlation first. The two variables have to be associated. Temporal precedence is the idea that one variable comes before the other in time. So in an experiment, if the research manipulates one variable and then measures the other, we know that the manipulation comes first, so temporal precedence is established. And then internal validity speaks to the idea that there's no other plausible alternative explanations for changes in the outcome variable. Variable A is the only thing that has changed. So let's go over an example. So let's just say we want to make the cause and effect statement that highlighting improves retention of information. It's highlighting that causes better retention of information. So in order to support this causal claim, a researcher needs to conduct an experiment. And in this experiment, one variable is going to be manipulated and the other is measured. So an independent variable is the variable that is manipulated. So in this example, one way to manipulate that variable would be really to give some people a highlighter to use, and other people would have to say read without a highlighter. So the independent variable is whether or not people read with a highlighter. They either have one or they don't. The dependent variable is some measured variable. That's the outcome. That's the effect. So in this case, we'd have to come up with some way to measure retention of information. So we can ask people to recall what they remember. We could just do something like a multiple choice test. We're going to give a multiple choice test that tests people on the content of whatever they read. Then there's the idea of random assignment. This would be a method of assigning participants to levels of the independent variable to try to make sure that each group is as similar as possible. So this is done by random, say flipping a coin or rolling a dice. So it's random who gets assigned to read with a highlighter versus who doesn't. All right, so how do we establish or how do we satisfy these three criteria of covariance, temporal precedence, and internal validity in an experiment on this does highlighting improve retention of information? Well, covariance would be established by seeing a difference between the highlighter and no highlighter condition in retention of information. So what you need to see there is, let's just say we went with the multiple choice test, you'd need to see the people that use the highlighter answer more questions correct than people in the no highlighter condition, right? So there's an association there. There's an association between the highlighter and test performance being an indicator of retention of information. So that's criteria number one. Number two, temporal precedence. Well, by giving participants a highlighter, that happened before measuring their retention, before they take the test. So you give people the highlighter, they read, and then their retention is measured. So temporal precedence is satisfied by manipulating the independent variable. Then finally, internal validity is satisfied by the random assignment to condition. Doing this should make the two groups similar on other variables that are potential confounds. So random assignment controls for alternative explanation. Because you might say, like, well, the group that had the highlighter, how do you know they're just not better at reading? How do you know they don't have stronger memories? How do you know that they didn't have more experience using a highlighter? How do you know that they weren't just better students? The answer is because people were randomly assigned to condition. So all of those differences that could be alternative explanations should be balanced out. That in the highlighter condition and the no highlighter condition, you've got people that are good readers and bad readers, stronger memories, less strong memories. But that's kind of equated across those both conditions. So those things can't be the reason. The only thing that is different is whether or not they used a highlighter. in addition to interrogating a causal claim using those three criteria, we would also want to look at the construct validity, external validity, and statistical validity. Okay, so construct validity, we're asking questions about how well the independent variable is manipulated and how well the dependent variable is measured. Okay, so do we have a good test of recall? Does the multiple choice exam, is that an accurate reflection of what they read? External validity would be about who participated, what was read, and how. Okay, so are these college students, or is this everybody? What was read? Do we think that this is only about kind of maybe academic readings or things that you read from a textbook, or does this apply more generally? Does this apply to, in the picture we've got a physical book and a physical highlighter. Does this work when you read stuff on the computer, right? So if you've got, your Adobe Acrobat file and you're using the highlighting tool, does that work the same way? So those are all questions that are related to, can we generalize these results to other people and other situations? Statistical validity, we're looking at the size of the effect, statistical significance, and then the idea of a confidence interval as well. So by effect size, what we're really asking ourselves is, how much of a difference does reading with a highlighter make? If we've got a multiple choice test and there's 50 questions, and people that read the highlighter maybe get one more question correct than those that don't, we might say, well, that's not a very big difference. Yes, I guess you could say the highlighting improves retention of information, but not by a lot. So that's, I'm kind of interrogating the validity of that claim, because there wasn't a very big effect there. And then, of course, we look at statistical significance and a confidence interval as well. All right, just want to wrap up with the idea of prioritizing validities. We might ask, which of the four validities is the most important? And it really just depends on what kind of claim the researcher is making and the researcher's priorities. So internal validity is really the top priority when we want to make a causal claim. So if we want to make a cause and effect claim, highlighting improves retention of information. Highlighting causes better retention. What we're doing is we're prioritizing internal validity. And what we're trying to say is it's the highlighting and nothing else that is responsible for improved retention of information. So internal validity is the priority when making a causal claim. But for a frequency claim, which you could just say like, oh, 55% of college students say that they use a highlighter when they read. What we're really prioritizing there is external validity, and then even construct validity as well. Okay, so it's what we want to say is like, well, did you ask enough college students? What types of college students? It's the priority there is more about the generalizability of that particular claim. And same with association as well. So external validity is generally prioritized more in a frequency and association claim than it is with a causal claim. All right, so that is it for the lecture about the three different types of claims: frequency, association, and causal, and how we would interrogate them using four validities.